Back again, trying to do a quick review on angles. Just title this one Angle Review. Just kind of prep you for a quiz or a test or anything like that that occurs. In astronomy, we have to deal with angles, particularly as we look at star distances and things like that. So, wanted to do a quick angle review. First of all, basically an angle, and I'm not going to repeat the lecture portion of it, is the intersection of two lines comprise an angle. So if you take something like this, an angle like that, so for angle A, this would be an angle. If we take another one, the intersection of two lines, something like that, that angle alpha would be, once again, angle alpha. This one would be angle A. Then we looked at the ability to be able to do like if you take an angle at, say, 90 degrees. I'm at this point not using a protractor, I'm just estimated that to be 90 degrees. Okay, see, this is angle N. So you can define an angle by the corner itself. So, or in this case, M, N, and then P. So that's 90 degrees or so. And if you have a line that exactly creates half an angle between 90 degrees, say 45, that's called a bisector. And again, I'm estimating it, but a bisector would be something that divides up into two equal angles. That's called a bisector. Now, the question is on angles, how do we measure them? How do we tell how far to take an angle? How do you actually measure the distance between these two lines that intersect, creating an angle? So we talked about we're familiar with a circle being 360 degrees. We explained the reason why. So what I want to do is I want to take and actually draw a circle as close as I can. I'm actually going to use a compass this time. I'm going to go ahead and draw a circle. We know that if I take the radius to the edge, and I'm going to make a bigger line than the edge itself, I'm using ink also. So from the center of the circle to the edge is my first line, and then I can draw any line from the center of the circle across as I go around the circle, and it would give me a total of 360 degrees. So this can go up to 360 degrees. We discussed the reason why that's 360 and not any other number. But now when we start measuring the angles, obviously if you go to a vertical, that would be 90 degrees. That's 90. And then 180 if we go to the other side. That angle from that center O, the circle, all the way up to that would be 180. 180 degrees. And if we go down all the way to the bottom, that would be 270. 270. So you get the idea, 270 degrees or so, all the way to 360. Now, the question is, how do we measure these degrees? How do we break them down, because we need smaller angles in astronomy? Well, one of the things that we do is we can use a protractor, and I'm going to take this line and draw a 1. I'm going to extend this line all the way out here. Try to make it as close as I can here. If I take that line and extend it all the way across, it's smeared a little bit, not a big deal. Now remember that we're going to use our protractor. That's the center of the protractor right there. right there. And then there's the base of the semicircle at either end. So I'm going to go ahead and actually put it right in the middle. Okay. Let me see if I can get this out of the reflection. I'm going to put it right there and very carefully line it up such that the base of this beginning circle in the protractor is lined up perfectly with that line, and our crosshairs is right in the center. So I'm going to draw a 1 degree angle. So notice if I zoom here, a 1 degree angle, notice that as I zoom, this is not exactly perfect. I'm going to go ahead and put it right where as close as I can, and I'm going to draw one degree right there. Would you agree that's 1 degree or so? Okay, so I'm going to go and draw in a different color the 1 degree line from the center, from that point right there. I'm going to put my pen there to the center of the circle. That's 1 degree. Okay, you know it's pretty small. A 1 degree angle is right here. That is 1 degree. Now, the way that we learn about this is you can take this 1 degree angle, this angle right here, 1 degree, and then we can divide it into 60. So imagine that I would go from the center of the circle and put in 60 lines in between the top of the 1 degree and the 0 line. Between these two line segments, there would be 60 divisions. That would be then 60 minutes. Minutes is 1 apostrophe. 60 minutes. Now it's impossible to draw 60 lines in here in the way I've got my diagram drawn. But imagine if I take one of those 60 minutes and I divide it into 60 seconds, and that's double quote seconds. So this is a very small angle. Okay, so this is 1 degree divided 1 degree divided into 60 minutes. Then I take 1 minute, this is 1 degree divided into 60 minutes. Next I take 1 minute and divide it into 60 seconds. So a couple of things you need to know. This is a very small angle. It's called 1 arcsecond degree. 1 arcsecond degree. Very small. So you would indicate an angle, a traditional angle. If you were very accurate in your measurements, you end up creating something like, for example, right here, I'm going to draw in green an angle like this, angle B here, ABC. So you could say ABC is equal to 38 degrees. If it was 38 degrees, I don't know. I'm just kind of guessing at that. 15 minutes, 12 seconds. That would be an accurate measurement of that particular angle. Okay. Now, having said that, that explains to you the measurement in degrees, and we're familiar with this stuff, except this dividing of the 1 degree into 60 minutes and then 60 seconds might be new to you. But there's a couple of things that you need to understand, that when we go into this operation, that 1 arcsecond is the same as 1 over 3,600th of 1 degree. Okay, this is an important thing to remember, because if we do measurements in astronomy that are very, very small, sometimes this is very helpful. Okay, and you know our traditional ojo, just keep an eye on that. Okay, that wraps up. I'm going to go to the back of the paper. You can stop it at any time on the video, but I'm going to go to the back to explain radians. Radians are another way to measure angles. So if we take a look at measuring in radians, remember that it's just a measurement of an angle. So if we take a look at, let's see, let me do another circle to illustrate this. Doesn't have to be perfect, but I'm trying to make it as good as close as I can. Okay, so I have my point right here. That's my O. My center. There's my circle. Now, the definition of a radian is if you have a radius of r and you have an arc length that is also r, the same length as you have here goes along the arc right there. If these two are the same, and of course the radius at the other end has to be about the same, not about, it has to be exactly the same. So if you have this R, R, R exactly in the piece of pie, then that measures that angle. So this measurement is length R is in radians. So basically the definition is if arc, and I'm going to call it A and B, if arc AB is equal to the same length as the radius, then angle AOB, AOB is equal to 1 radian. Okay? So now the approximation of 1 radian is 1 radian is equal to 57.28 2958 degrees. Sorry for the interruption. I'll stop it right there. Thank you.